four exceptional speakers who will share
They are also excited. Anyhow, let's start for them. It's because of the date or whatever is the working time, I don't see much of them.
MBA. Mike possesses the technical expertise and business acumen to navigate the complexities of the future maritime landscapes. Beyond his professional role, Mike actively contributes to the industry by volunteering as the current chairman of the Singapore Joint Branch of the Institute of Marine Engineering, Science and Technology and the Royal Institute of Naval Architect, RINA. This dedication reflects his passion for advancing the marine industry as a whole. Please welcome Mike on the stage with a round of applause.
Okay, thank you very much, and it's very good to be here, definitely, as part of your celebrations of 10 years, and with obviously a very large Bangladeshi maritime community. I did my tickets in South Shields, and I was telling somebody earlier on that the majority of my classmates when I did my seconds and my chiefs were from Bangladesh. And when I was speaking to somebody about this yesterday, they said, I didn't know there's that many Bangladeshi seafarers. I said, yeah, there's a massive coastline there, and it's also a place where many vessels get scrapped as well. Anyways, good to be here. I'm going to cover some stuff on alternative fuels. I'm going to take you through some of our stuff from Bureau Veritas on the World Order Book, and the dependency for the future of those alternative fuels with regards to the production pathways, and then covering a little bit of the safety and design elements that have to be taken into consideration for the kinds of vessels that are going to be running with these alternative fuels. And we've all heard quite a lot about alternative fuels, and it's a constantly moving topic. Okay, so a little bit about Bureau Veritas, because most people would know Bureau Veritas as a classification society, but actually it's a lot larger than that. We employ around about 83,000 employees. In the marine side is about 2,600 employees, and our marine side is approximately 10% of the business. The rest of it is in testing, inspection, certification, in commodities, industries, facilities, in consumable products. So a lot bigger than just what we're used to, and even what I knew before 2 years ago walking into Bureau Veritas, is that there's a lot more there than a marine classification society, which allows it to actually, in my team, we lean heavily on the other parts of Bureau Veritas to bring things together. If you were at the Singapore Maritime Week this year, you would have seen a wings and ground effect vessel close to the Bureau Veritas display. And this is with ST Engineering, the Airfish project. This is something that Bureau Veritas is working with. This vessel, when it gets up to 80 knots, it runs at about 2 meters above water. And that's not something that really we could understand very well, being a marine side, and that's where we lent on our Bureau Veritas aerospace and aeronautics division to help with the flight mode for that, still classed as a marine vessel because it's below a certain level as well. So yeah, there's a lot of stuff that we're doing in BV. So going on into what we're talking about and setting the scene for some of the decarbonisation side, when we look at shipping, there's around about 90,000 vessels on the seas, and 80% of the world's goods are transported by shipping. That's a massive role for the marine industry to play. But the marine industry emits around about 3% of the world's greenhouse gas emissions. And in terms of total energy, we're looking at 3,000 terawatt hours, which is, in perspective, if shipping were a country, it would rank today at about 10th place. And so that kind of just shows us the relevance of the marine industry in this whole thing, and the requirements that are being laid out by the IMO that we have to comply with. So just to highlight, we've done quite a bit of stuff on alternative fuels. There's a white paper on life cycle assessment of fuels, which is something we're going to start to see coming through the IMO. And also a position paper on decarbonisation trajectories. I'm not going to cover it during this presentation, but one thing I'd like to highlight about that is that when we looked at it and said, if the maritime industry is trying to get to zero for 2050, as compared to 2008 levels, it's a really, really hard ask. And we used modelling to have a look and see how achievable this was. And even some of the best estimates had us overshooting it by 5 to 10 years to like 2060. So it's, even with all the alternative fuels and all the technologies, it's still looking to be particularly difficult. So we're going to be looking at these fuels. These are most of the fuels that you would expect to see in the alternative fuel landscape. And they're at relatively different levels of maturity for coming into the marine industry. So hydrogen, ammonia, methanol, the biofuels we're seeing more of, and already we've seen a lot of uptake over the last 10 to 15 years on LNG and LPG fueled vessels. So here I'm trying to show those fuels as well, but showing that the production of e-fuels from green electricity and biofuels from biomass, along with blue fuels, are likely to become the norm. They're the fuels that you're likely to see come through, and those are the ones that we really need to achieve the decarbonisation side of this, right? So we may be looking at vessels which are being fueled with methanol, but it depends on the colour of that methanol. A large majority of methanol is actually produced from coal, and when we start to look at the life cycle analysis of a fuel, then we could see that methanol actually could be worse, more of have a larger carbon footprint than that of conventional fuels do currently. And that's where we look at the well-to-wake approach. So currently, when we look at emissions and how they're covered, we look at, when we talk about the emissions which are produced by a vessel, we look at the tank to wake. So that's the fuel on board from the storage and through to the point where it's burnt inside the engine. Whereas what we would likely to see coming forward is the well-to-tank approach, where we're looking at where that raw material acquisition is, what kind of fuel production is going into it, how much transport and storage there is, and what's involved in the bunkering process. And this will all add into the entire carbon footprint of that fuel, and therefore, leaning back on what I was saying in the previous slide, that it will put that fuel with a different requirement to it, or a different level of carbon emission to what it would be if you were just burning it in the engine. So to look at our world order book at the moment, the vessel numbers for alternative fuel vessels are continuously growing, and making up over 52% of the world order book by gross tonnage. And if we instead look at that instead of gross tonnage, we look at the number of vessels, we can see that this illustrates that the new build vessels with alternative fuels are significantly large in terms of gross tonnage than the new build with conventional fuels. And this is due to our order book being made up of container ships, LNGCs, and pure car carriers, which are on average larger in gross tonnage than the average vessels. And if we look at our order book alone, you can see here that the alternative fuels account for 69% by gross tonnage, and that doesn't include the fuel prepared notation vessels. So the fuel prepared notation vessels are the ones where you'll see vessels that have a notation that says ammonia ready or methanol ready, right? And those vessels don't necessarily have anything other than maybe an MAN engine installed on board, which is capable of being retrofitted to have burning for methanol or burning for ammonia, or the vessel has been assessed to see that it has the ability to have ammonia tanks on board, etc., right? And so this doesn't take into account of that, so it's not, the data has not been skewed here, right? And our total order book is looking at 23 million gross tons, and that's with 243 vessels being alternatively fueled, which is about 15.7 million gross tons. And I took this slide here from Clarkson's data earlier on in the year, and this shows that 6.2% of the world fleet is already using alternative fuels, amounting to a total of 1,376 or 101 million gross tons, and a large proportion of those are gas carriers, right? So they have the fuel on board and they're burning those. And from my own history, like when I was working, I worked for BP for 15 years. Our rules for the alternative fueled vessels, and these have been developed essentially keeping up with the market movement. So we've looked at it and gone, what was likely to be required first? So methanol came first. I mean, not out of this, but more recently methanol, and then ammonia, and then last year we did, in November last year, we published our hydrogen rules. And that's because you're not likely to be seeing hydrogen fueled vessels anytime soon. And ammonia also is not looking to be one of those fuels that although it's been in the press in Australia and in Singapore, these are all pilots at the moment, so you're not likely to see this becoming very, very common in the immediate future, and most likely it's the methanols and the LNGs that are going to be there, and it's going to be dependent on the fuel pathways as well, which will be needed to support these fuels. So this image here compares the volume of various alternative fuels if they were in a tank on board. Of course, these are not the containment systems that are there that you would expect to see on board the vessel, but it's just to show you the energy density, really, you know. And this is comparing it to traditional marine gas oil, right, with MGO being a baseline of 1. So when we look at LNG, of course, it requires more space due to the lower energy density. Methanol is similar to MGO. It's slightly denser. We're looking at about 2.5 times that of MGO. Ammonia is 1.5 to 2 units, and it has a lower energy density than LNG. And then liquid hydrogen has a significantly lower energy density and requires a lot more storage, right? And the key takeaway from this this diagram is that while some of the alternatives offer the very good environmental benefits, their lower energy density translates to needing significantly more storage space on board, and therefore impacting probably the most important part of the reason for the vessel's existence, which is the cargo carrying capacity and therefore requiring larger fuel tanks and having a knock-on effect to the range of the vessel as well. So this table here, we've compared like for like for a Kamsarmax 81,000 deadweight ton that travelled 64,000 nautical miles over 5,700 hours, and what kind of comparative cost, 64 knots, nautical miles compared with, and what it would look like compared to various other fuels. And of course, we'd expect these prices to change significantly, and they already are, as the supply is increasing and all the parts of the puzzle begin to fit together. And that comes back to that whole framework that's required across the world. Singapore's working on it, but it needs to be linked together between all the ports to make sure that there is methanol bunkering, to ensure that there is ammonia bunkering, and that there are the production pathways for it as well, you know. When it comes to alternative fuels, there's a large number of different hazards, and of course most of them have a risk of fire and explosion, but there are some other considerations to take into. If we look at hydrogen, the hazards are different for pressurized or liquefied. Hydrogen, which is compressed at 700 bar, versus hydrogen, which is liquefied at minus 250 degrees C. And both of those present their different dangers as well. Further to this, hydrogen processes, the quality of it causes hydrogen embrittlement of metals, and that affects where hydrogen atoms become trapped within the metal's crystal lattice structure, which weakens the metal, and these cracks can occur even under stresses below the material's normal yield strength. So yeah, with the LNG, yeah, we're looking at pressure and its cryogenic storage, and ammonia. One of the big things that comes up is the toxicity, and I will cover that in the safety area of the alternative fuels. Is that how we get around ensuring that the fuels which are used on board are safe for the people who are working in the engine rooms. And this chart here is looking at that auto ignition temperatures and the flammability limits in air of the various alternative fuels. When we look at it, there's ignition difficulties for methanol and LPG, which have lower auto ignition temperatures than methane and hydrogen, which makes them easier to ignite accidentally. And ammonia has the highest, which makes it much more difficult to ignite. And you'll have heard from MAN and WinGD, who've been developing their engines, of the difficulty that they've had in actually making those fuels ignite easily and work with those engines. When we look at the flammability range, hydrogen's got the widest flammability range, meaning it can ignite in a wider range of fuel-air mixtures, and this can be both an advantage, as it's easier to maintain combustion, but also a disadvantage due to the issues of leakage is likely to find a flammable concentration and lead to explosions. So when we look at fuel safety and the adoption consideration for regulations and the maturity of that framework, that has to be considered. And there are no barriers by the regulations, and the innovation pathway and alternative design can be used. And the current framework looks at local as inland, national for coastal, and international. And that local side is focusing on the inland waterways and the river transportation, the regulatory bodies of the national and local authorities, and the maturity varies depending on the country or the region. At the national and coastal level, which applies to coastal waters and short sea shipping, the regulatory bodies are the national and regional authorities, and the maturity there is more established than inland regulations, but it can vary by country. And when we look at the international side, it's the side that we're probably more familiar with SOLAS. The IMO, they're developing those international standards for maritime safety and pollution prevention. And then we have the IGF code as a basis, as part A, which applies to the use of gas and other low flashpoint fuels. And then the SOLAS for the alternative design equivalence, which allows equivalence to SOLAS requirements for novel ship designs or technologies, and requires case-by-case approval from the flag administration. And the maturity is less mature than standard SOLAS regulations, but it is a pathway that has been used. And then from our side, from BV classification, we're there to help provide the rules and standards for the ship design and the construction and its operation. And of course, it's not mandatory by international law, but widely adopted by the flag administrations and the shipping companies. And we've been around for quite some time, so able to and have a lot of experience already in the LNG vessels and methanol vessels already. I've got 10 minutes to go, and I'm going to cover a little bit more on the safety, a little bit of design for each of our rules, but I don't want to go into too much in depth on it, right? I'm quite happy to share the presentation afterwards and to follow up on any questions that there might be. But I already covered that with hydrogen design, there are some key areas that need to be focused on, and material compatibility has a significant role due to the dangers of hydrogen embrittlement. And this is relevant regardless of whether it's a compressed hydrogen gas or a liquefied hydrogen gas. And it's an area which is still under development. Types of containment, different types of containment being experimented with. There's a number of projects underway. My team has been supporting some companies who are answering the MPA and CS IRO grant request in Australia. So it's part of that collaboration between Singapore and Australia. And a lot of those companies are looking at how they're pushing the development of the different types of containment to support the smaller vessels who have like hydrogen fuel cells, and the larger ships who are looking to either transport hydrogen or to have hydrogen storage on board for future things. We've got some owners who are looking at hydrogen fuel cells instead of their generators. If we're looking at ammonia, we need double wall pipes, very good detection systems, and an onboard ammonia treatment system, which looks similar to a deck seal you would see on a tanker. When we look at methanol, it's less of a problematic fuel, but it still has certain dangers. And due to its very high flammability, it's important that the ignition sources are limited. And the same with ammonia, it also has double-walled piping, but it's more so because of that flammability than for the toxicity side of it. And you'll see here that the cross-section through the tank, the fuel tanks, they have to be cofferdammed and also inerted. And then, once again, looking at the fire safety side of things, methanol, it's not visible when burning in the daylight, so only in the dark. And therefore, smoke detectors in combination with detectors which are more effective for detecting alcohol fires. So the use of infrared and UV type flame detectors are needed with this. as well as for firefighting. We need to have alcohol-resistant AFFF foam in the fuel preparation rooms, and below decks, and similarly with high expansion foams, which is alcohol-resistant as well. And now I'm just going to cover quickly some bits on biofuel. There's a lot of people looking to utilise biofuels more now, and they are looking to be a good way to trim emissions, and you can get an existing vessel to run with biofuels for a number of years actually, just by adjusting the quantity of biofuels there. And so, providing that biofuel is certified correctly, and therefore it has to meet certain sustainability criteria as well for it to actually be considered relevant to be used against the IMO, DCS and CII reporting. And here, I've put this up, it's 3 scenarios for CII. And here you can see if we were using a B25 mixed with heavy fuel oil, it could allow a vessel to remain compliant with CII at level C until 2027 before dropping to a D, which means it's still actually relevant and can still keep on going, because it's only then that you're issued with a request to come up with a plan of attack to reduce your emissions in line with reaching level C again, until 2030, where that vessel would reach a level E. And with a B100, this vessel could also maintain the level C longer beyond 2030. But the question is, in that area, is what are the effects on your engines, and what are what's the compatibility with your engines as well? And there are some owners I've spoken to who've had risk assessments done and had issues with running with biofuels higher than B24, and that's led to them having lots of downtime as well. But biofuels got certain challenges. One of those is the cost, and the prices here are slightly outdated, as they have come down slightly, but it's still a higher cost. And then you have to take into consideration the lower calorific values, and problems which can come with biofuels, such as microbial growth, and that leads to excessive sludge. I sailed in Europe with some of these fuels some time ago, and yes, microbial growth was a big issue, and that led to blackouts on board vessels due to clogging of filters, etc. And the other side of that as well is there's a lifetime for how long you can store these fuels. The storage of these fuels, they can lead to deposits which come from the oxidation when they're stored for too long. And the thing is, as this comes down to the crew training side, the crew need to be aware of these issues. They need to know how to deal with them. They need to be trained in handling of it. Same with all other fuels, but this is probably more pertinent because it's a fuel they're likely to see right now. And I wouldn't say it's a big issue because I only came shoreside in 2017 myself. What I can say, and I'm sure everybody else would agree who's been saying themselves, that crews are very adaptable, and we generally move with the evolution of technologies and new regulations as laid out by different countries, zones, etc. When we look at the emission zones in Europe as well, similarly to dealing with that. And so that's the whole picture of all the alternative fuels at the moment, and we're waiting for some of the interesting stuff to come out of the MEPC 82. Bureau Veritas will be running a webinar next week on the outcomes of MEPC 82 and looking at what that means for owners and the vessels that are trading around the world. So with that, I thank you very much, and I hope you found it informative. Thank you.
Very much, Mike, for your invaluable knowledge sharing. Please join with me with a big round of applause for Mr. Mike Watt. Next, we are honored to have Captain Forkanul Quader, who began his maritime career in the year of 1967. Having graduated from Bangladesh Marine Academy, he had a dazzling course of highly regarded and colorful professional seafaring journey from almost 18 years. He qualified as a Master Unlimited and later acquired MSc degree in Maritime Education and Training from the World Maritime University in Sweden. With his distinguished coffer of multi-force experience, he sailed and commanded many commercial and specialized ocean-going vessels of various capacities under various flags. He joined the Maritime and Coastguard Agency (MCA) of the UK Department of Transport as an examiner of masters and mates. It's a surveyor. He successfully served the MCA for over 19 years. Among notable tasks, he has done flag state audits of maritime training and certification arms in India, Vietnam, the British Virgin Islands. That included also representation at the IMO, flag state and college audits, and a spell of port liaison policy manager at the MCA. His other accomplishments were the training institution audits in China, France, Italy, USA, Ireland, Trinidad, Antigua, and the Philippines. Captain Quader regularly represented at the MCA at the IMO's HTW and NCSR subcommittee meetings as one of the UK delegates. Having participated in various IMO correspondence and model group as MCA representatives, he contributed to several IMO resolutions, circulars, and model courses. Thereafter, honorably carried his charter of duties till he chose to formally retire in November 2021. Presently, he spends a slice of his time as a freelance examiner or trainer for various grades of marine professionals. Captain Quader has numerous references graded publications published in different spectrum of reputed journals and publications, with the latest being the Shipmaster's Business Self-Examiner published in 2024.
Such introduction, I not deserve. It's like a homecoming for me, Singapore here. And good afternoon to all of you. Good afternoon, Salamat Tingahari. So, to you all. And it is, as I say, it is a homecoming for me. I'll take a brief few moments just to recall that I studied here for my first exam, which is the second mates exam. I passed my exams here, which is a lucky for me indeed, lucky city. And a lot of memories here, including the memory of my two closest friends who I lost recently from here in Singapore. One is Mr. Zafrul Alam, Chief Engineer, and a renowned person, an accomplished person known in the IMO and worldwide, as well as Captain B.I. Qadri. So I fondly really remember them and pray for their departed soul, as well as briefly taking this time. I hope I don't intrude into the introductory thing of the BMCS president, etc., for his talks. But I must thank the BMCS president. That means my profound and heartfelt thanks to the president, Sanwa Ditu, BMCS president, and also to General Secretary Shakawat for such a wonderful, hospitable, welcoming sort of thing that he gave us. And it was really unexpected, more than we expected. That was the thing I would say. At the same time, I fondly remember all my pioneers that they have given me a lot of wisdom and good thoughts, as well as all my colleagues and juniors who has also helped me all the way. And yes, and those that we lost and those departed soul, I pray for their soul, and I hope the Almighty Creator will place them in the highest place in heaven or Jannah. So that is the brief thing there. Now I'll come back to my own topic there. The future of maritime education and training. What can we do to prepare for the challenges ahead? As you just heard Mike, the challenges are coming, enormous challenges we face now. And are we really prepared? Of course, many of us are concentrating on the fuel change, etc., without thinking the human behind it. We hardly seem to think of the human behind all these things here. I'd like to touch on the following thing there. That maritime education training, that is short for MAT. Where are we now? Just touch on that a bit. That is Merchant Navy Deck and Engineering Cadets and Officers. Obviously, there are other seafarers, which not really, at the moment I'm touching is too much within the time frame here. And the other ones, what are our challenges that we always talk about? What are the factors to consider, should we consider about it? What are the compelling needs that we need to think about? And studies and research, are there any research work on that? What can we all do to help prepare for the future? Yeah, these are the salient questions there and the way forward. These are my topic area. Specific areas to influence others. Yeah, that's what we can look into. And choices that we have. This is simply a snapshot that is from the breweries, that what sort of world fleet today we have. There's 93,000 ships at the end of 2023. Another colleague found it, I think in 93. I found it a little bit less, but it is around there. But I'm concentrating on the number of officers there. Deadweight tonnage is 2,224 million deadweight ton. Seafarers 1.89 million. Out of that, you can see the requirement for the officers. It is more than 680, that means 680,000 officers are required. Whereas the supply, it's more than 700,000 is required. Supply is only, at the moment, it's running up to 685,000. So that means there is a shortfall in terms of percentage there, you can see. Seafarers, that means officer shortfall, not accounting for the seafarers themselves. That means that we have so many shortfalls there, they are coming up, as well as the others are there, so we need to think about this one as well. At the moment, maritime education training, where are we now at the moment, at present? Nautical engineering, these are the two streams at the moment we have. We have obviously electronic engineers and others, that means ETUs and working on board. So those are the other streams. But do we need further down the line, more and more? So you can ask questions to yourselves. Many countries follow a blended system for our marine officers. That means former college-based education and training plus practical experience on board ships and shore. Parallel to this, there is opportunity for experienced seafarers to progress and pursue their career at sea. And unlimited near coastal and domestic, that is the picture at the moment we have under the STCW convention. STCW means Standards of Training Certification, Watchkeeping for Seafarers. This is the convention we have at the moment. Convergence, filtering from other routes, from fisheries, from yachts, from navy, from coastal, they are also filtering into this mainstream here. And dual qualification in Europe, they have dual. That means you can join as a deck or engineering officer and you can have dual qualification and can go up. Another stream we have is a 4 or 5 years degree program, which Bangladesh also have this degree program. They can earn degree along the way. So these are the current pictures we see. What I think if you look at the future, possibly there's going to be a lot of changes to a lot of things here. You can imagine. Maritime education training, where are we now? Still catching on that. Core elements, what do? We study the convention that tells us that these are the minimum that you have to learn, or knowledge, understanding, and proficiency. In terms of knowledge, in terms of understanding and proficiency, we do that convention-wise. The minimum standards required worldwide. I think some of us may wonder if you are in the side profession or something, why are there a minimum standard? Minimum means that's the worldwide minimum. We need to have some sort of bar there that everybody should achieve that minimum to be on at sea. Because ships just don't stay at one place. They go from one country to the other. So you can see the thing that they have to be prepared for that. The college, academic education and training, practical sea experience, that's what we do at the moment, and workshop experience or training afloat, and knowledge, understanding, proficiency at college, base qualification, either baccalaureate or undergraduate, they earn. And knowledge, understanding, and proficiency assessment is done on that. And we have sort of viva tests. Some of the countries we take face-to-face oral or the virtual, sort of ask questions to them to see whether they are up to the mark or they can really stand the pressure of the sea, etc., to see the test there. This is the current trend, and oral is viva that we take. It is now becoming all virtual. You take one exam on the computer, maybe if you can get through, then you can face the music either virtually or face-to-face. This is the current sort of trend here. And professional academic qualification you earn and you go to sea. What are the challenges now that we face? This is where we need to think about. STCW at the IMO, it is up for, that means another overhaul is going on. That means STCW convention is being looked at so that they can put things and then complete revision of STCW can be done. That's what they are undertaking now. Maritime Safety Commission has already agreed. So it is an agreed thing. It's not that it is coming, it is really coming. And the ILO. ILO also at the same time has a lot of things filtering back to the seafarers. We need to learn about the ILO, what are the requirements in terms of minimum sort of seafarers, what they can get or what they are entitled to, wages, etc., their repatriation. So from there also you need to learn a lot of things. You not only learn the technical side of it, you have to learn from the ILO side and as well as the other STCW convention side and many other things. Then technological and design and model sort of changes that is coming. There is going to be huge technological change. One of them might just touch the tip of the iceberg. What other things that is coming really, it is, you just look at AI, artificial intelligence itself is a big wall that would open up very soon here. MAS, Maritime Autonomous Ship System, one of my colleagues is going to speak about it later on, so I'm not going to really stay on that too much there. That means that is also autonomous. In future, possibly autonomy is coming to the shipping. That we have expected this for a long time that is going to come, and it is going to happen. It's already happening in Norway and all. They are running autonomous ships. Japan has been running it. Now Norway is running it. So it is not that it's not going to come, it is going to come. So we need to be prepared for it. These are the challenges that we face. Information technology, IT is at the fast pace. Now you see we can't do without a mobile phone. That technology is already there. And people are talking from the ship virtual sort of thing they are doing. That means information technology is leap bound, is moving such a drastic speed forward. Even we just blink your eye and you are still one step forward there ahead. So we need to be either ahead of the game or we need to keep pace with it. Are we ready for it? This is the question I'm saying that we need to ask. Increase the specialization of ships. Increase it. Really total regularization of the ships. Passenger ships, oil, chemical, gas, offshore, and further is coming, specialized vessels, even ice vessels, etc., or many other specialization, even offshore vessels, or the ships that they do exploration, etc. So that means you can be on any of those vessels sailing tomorrow. Artificial intelligence, as I said, artificial intelligence is something that is not, we are waiting for it. It will be just upon us very soon. And we need to deal with it. And that's what we have been doing all along instead of being prepared for it. Now, at this moment in time, I think we need to be really prepared for something that is coming. Not wait as we did 20 years ago. We used to wait for things to develop and then we learn about it. Carbon neutrality push, which you have heard Mike just now, there's more carbon neutrality, there's sales coming up, there are other things coming up. So where do we start? We need to know bits of this, bits of that, everything possibly. A person has to be at sea, that means he needs to tackle those. Nobody else is there in the ocean. Educational needs is coming. More and more people wish to learn. They want to earn some sort of recognition that I should have a degree, I should have this, like another friend of mine. So educational sort of leap bound is going forward. Environmental changes every day. Not only just carbon side of it, people are more conscious of what we eat, what we do, how we move. That means environmental changes coming up there. Psychological changes at the same time. We never thought in our time, 20 years ago, about the mental health. Never heard of it. Now, you hear it every day. So think about it. Social and human needs, social and human interaction. So we need to learn so many things there. Expectation of present generation for sustained future. Present generation, believe me, we are standing at some way back there. Future generation, they are far ahead there. We think that possibly they know less or we can possibly tell them what to do. But their really expectation of present generation is much higher in terms of sustainable future, energy and environment. They are very conscious indeed. To lifestyle, how do they lead, clean life and everything. They think every day. Think of Greta Thunberg, and then you will know how they think. Now I will show you some slides. That is the futuristic ships that's coming. This is Aquarius Eco Ship, zero emission ship design utilizing wind and solar power, both together there. They can turn as well as they can gather the energy from the solar energy and can run on that, as well as from the sail. So sail can turn and you can vary either your turn as well as your speed, etc. This is coming up, new ship design capable of supplying hydrogen using green ammonia. Imagine, Mike just touched on it there. And these are the shape of the things that is coming up there, sail vessels. It's auto sails, they can turn almost like 360 degrees they can turn. They can turn, they can stop your ship. These are the futuristic ships that's coming up there. This is already was there, this last one here. Shin Toku Maru, that was in 1980, they have run this ship in Japan. So you can imagine, people have been thinking about all this, but we are being left behind in terms of education and training. We are still learning those things that we learned earlier, and still haven't changed anything on the knowledge, understanding, proficiency, or should it be something else? So this is what is the big question for us actually. Yara Birkeland is a groundbreaking vessel that combines zero-emission technology with autonomous navigation. It has been running for a few years now. I don't know whether I have a video clip here, whether it will run. Let me try and see. This is the ship, actually, Norway, and Georg, that's running here there. I don't know whether you can control from there. Not sure whether this will.
We've heard about self-driving cars and maybe trains, but there could soon be unmanned ships that are navigating open waters. In Norway, an all-electric and what is expected to be the world's first autonomous container ship is beginning a 2-year pilot, as Adrian Murray reports from the south of the country.
Cruising quietly through a Norwegian field, this new ship is making waves. It's sailing to a nearby port on a voyage that's emission-free. At this fertiliser plant, up to 100 containers are loaded onto the Yara Birkeland. Here in the dock, this looks like an ordinary cargo ship, but under the deck, there's no engine or diesel. It's powered instead by batteries. There's a capacity of almost 7 megawatt hours, enough to power 90 Tesla cars, and that's supplied with clean hydro energy.
So what we see right here is
And if everything is ship-shape, 2 years from now, there won't be any crew on board at all.
In the beginning, I will be driving the ship more or less as I do today, and more will be taken over by electronics, robotics.
Data collected will train an algorithm, and eventually radar, sensors and artificial intelligence cameras will help the vessel navigate by itself. Docking, loading cargo and recharging batteries will also be automated. Both the fertiliser and shipping industries are big emitters, but around 40,000 truck journeys each year will be taken off the roads, saving 1,000 tonnes of CO2.
Now it is crew supported by autonomous systems. Then it will be autonomous systems supported by crew on board. And in the end, it will be autonomous systems supported and watched by crew in the shore control center.
Voyages will be monitored from the land, and if needed, a human could step in. Smaller, unmanned boats are taken to the water, while autonomous subsea drones have already made a splash.
What I'm saying that the Maritime Safety Committee has already aware of all this. They are already working on autonomous ships and therefore agreed to a roadmap to the development of a mass code. So there will be a code for marine autonomous ship system. There will be a code that is non-mandatory. That means the initial one will be as follows, non-mandatory. May 2025, finalize and adopt non-mandatory mass code. There will be a code there from the IMO. So people have to learn about it. First half of 2026, develop framework for an experience building phase, that means EPB, building phase. And 2028, commence development of the mandatory autonomous ship code based on non-mandatory code and consider amendments to SOLAS new chapter for the code adoption. That means there is going to be a mass code already agreed. So that is coming in. We have to learn. If I'm going to be sailing, I need to learn about it on mass ships. That means you can see that's an added thing for us. This is just simply one side of the picture. We will still have our conventional ships belonging to a lot of countries because everybody cannot change vessels overnight. And then we are going to have autonomous vessels sailing there, and we will have some transitional vessels. So you can imagine people have to be trained to face music there. by 1st July 2030, adoption of mandatory code for entry into force on 1st January 2032. That they are just put it according to the carbon neutrality changes that is coming by 2050. IMO is saying that it should be carbon neutral. What are the salient factors to consider? What should be considered? As TCW Convention Code, yes, uniform approach needed globally. We all know that there should be a uniform approach to that, not just for one country or other. Everybody should have a similar, that this code will be changed for everyone there, needed globally. Global approach is needed. We have had a lot of the talk in the past that it's not globally, it's not uniform. Some countries are following this standard, some countries are following possibly different standards, just following the minimum. KUP, that is the knowledge, understanding and proficiency. Should we consider KUPP, maybe add another factor there, adding performance to that, proficiency and performance-based approach maybe. So that is things to see in future. Development of KUP, a balanced approach is required worldwide. Routes, structured versus experienced routes. Reassess, we need to possibly reassess the routes that we currently have. What sort of things, shape of the things should be considered for future. Use of simulator, how best and to what extent. We are already using simulator. It has been introduced for the last quite a number of years now. Now we need to think, how far can we go with that? To what extent? If we apply fully simulator-based training, is it really worth it without the practical sort of knowledge or experience? Because shipboard work and practice is quite different. You need to have practical experience together with other experience, that is not just the simulator training, and I can't go and drive a car or something like that. Virtual reality, augmented reality, and artificial intelligence. These are the shape of things to come, and we need to consider those. Sea service, reassessment of minimum at different levels, stages. Simulator training alternative, we can think about it. To what extent? How far should we go? Training records, uniformity should be there regarding their records of training. Workshop, on-the-job training practice. Training record book versus portfolio. Should we have a portfolio that what they do, they note it down and then people are assessing it? So these are some of the things that we need to consider the factors. Technical officers, still we have the communication side of it. We need to look at it. Dual certification, common approach. Should we have a common approach? Because you saw that captain of that vessel, autonomous vessel, saying that because he is the only one there. So should we have a common approach for future? These are the factors to consider. Radar and communication technology not going to be like today. It's going to be far advanced, more advanced. So we need to be prepared for that. Inspection, survey, and maintenance will still be there, and we still have to learn those techniques and games. And we have to still face those surveyors and all. To shipboard personnel, you can see the long list of the things they need to learn. But where and when and how, this is how we have to see. And while we have the opportunity, I'll just come to that we must do something. What are the compelling needs? Over ever-changing world, expectation versus achievement. Youngsters nowadays, future generation, they have expectations versus achievement, what they achieve. They do evaluate nowadays because they are very much computer literate. They can see what's happening around the world, so expectation is very high. Advanced technology built upon foundation knowledge, that's the basic knowledge. Meeting the expectation of our future generation, forward thinking, forward looking. We need to look really far, a bit ahead there, together with them. Fit for purpose, it has to be fit for purpose as well. Need for balanced blending, C plus education training, hands-on, or plus we can add to that. Skill development mindset, we need to change our mindset. So far in the past, we have been sitting on our mindset, never really wanted things to change or something. People don't like change. Global uniformity and approach is required. Assessment strategy and uniform approach. What sort of assessment strategy should be there? Should we assess them while they are doing practical, or should we assess them as we do now? Management of quality standards. This is one of the factors that in my experience, I mean, while we do audits and all, we find that is lacking to some extent, that quality standard is not exactly same. Consistency and quality should be there. Audit and inspection, consistency and uniformity. Substandard institutions and system issue, urgent need to address this one here. So these are the things that is needs are there. Energy efficient operation of ships, SEEMP they call it, but the ship energy efficiency management plan. Education training for future, common approach is required there. Sustainable development in maritime education and training. There should be sustainable development. Global effort and collaboration to create rounded individuals. This is how we need to possibly think about the future. Studies and research, I will not spend very much time. I've got also written up this one. I'll try to share the slides as well as the other one with you. I have already got my own slides in terms of written down summary, synopsis. According to a recent research regarding this SEEMP, that means Ship Energy Efficiency Management Plan, exploring seafarers' knowledge, understanding, proficiency in SEEMP. They only looked at these people only looked at the Ship Energy Efficiency Management Plan. They did not go into the entirety of the education and training. So only this research shows that there is more to learn than we can imagine. A strategic training framework for enhancing seafarers' competence in energy efficient ship operations. This is one area that they have looked at. So their view is that I simply got the clips there. Therefore, continuous education and training for crew members are essential for successfully adopting energy efficient. You can see there, for energy efficient measures, energy saving measures and technologies on board ships. Moreover, the MEPC, that's Marine Environment Protection Committee, that is 213 circular, that's 63rd session there, resolution, states that SEEMP success depends on raising awareness, training of onshore and onboard personnel. So onshore as well as onboard personnel is required. They further looked at things there. A combination of individual, organizational, technological, and environmental factors influence the implementation of SEEMP, that is simply SEEMP twice, seafarers on board ships. However, the crucial element encompass awareness, knowledge, communication, skills, motivation. See how many factors are there. Educational training, technological solutions, overcoming barrier. These are needed on human, so you need to change or you need to help them understand. This holistic understanding illuminates the intricate interplay of diverse factors driving seafarers towards energy efficient ship operations. You can imagine people have to be really, they have to really gear up for future. For energy efficient measures to be effective, seafarers to possess a good level of knowledge and cognition. Cognitive knowledge is required. Crew members who have been adequately trained, have learned the importance of energy efficiency and are aware of it, are more likely to consistently prioritize energy efficiency in their shipboard duties and adhere to the company strategies. That means they will be more geared for the energy efficiency if they have the training. In preparation for the IMO's ambitious goal of achieving net zero emission by 2050, the maritime industry requires extensive education and training program for enhancing seafarers' competence. The maritime industry needs competent seafarers equipped with proficiency in digitization, information technology, artificial intelligence, technical expertise to navigate the challenges of the decarbonized future. So you can imagine, even at the initial stage of this research, these people are saying that they need to be trained in many other things than we think of today. But that is surface scanning study did not go far enough because they looked at only one factor, SEMP, that's the Ship Energy Efficiency Management Plan. Specific to SEMP, non-holistic approach there, and methodology and approach fell short. Even in their language limitation, the study lies in the simple bias. So they have concluded this. The study received fewer responses from seafarers who attended EEOS courses only, energy efficiency course. Another limitation is the small sample size used in this paper, which can influence the results and leading to some uncertainty. So their paper fell short a bit, but in future more research will be done. What I'm trying to convey is that who do you want to see? Here is a lot of industry people, you are all here. So who do you want to see on board future generation of ships? I mean, who do we expect there to be for safer lives, safer ships, and cleaner seas? This is the theme the IMO has, and this is what we need to think of. An officer who is probably, this is AI ready, environment ready, digital ready, possibly, work ready. Yeah, he needs to work as well. Technology savvy, sea ready and future ready, and possibly the world ready. The other is to go places. So these are the kind of people possibly we are looking at. Can you imagine? It's like a robotic world is coming maybe. But I'm not trying to frighten anyone here. All I'm saying that we need to think ahead. An officer who is, what can we all do prepare for the future? Opportunities that we have. We possibly have, this is the lifetime opportunity we have. We cannot shy away from our responsibility towards the future generation seafaring officers. Just like the environment, they are saying again and again, I'm a Secretary General, that we cannot go away from the responsibility that we have, general seafaring officers and cadets. No matter what are the circumstances today, future is rushing towards us, towards the next generation, and time is of essence. Time is running up. We have a duty of care. We do all have a duty of care. Can we do something for them? Yes, we can, and yes, we must do something for them. As nations, we can work hand in hand to persuade our administration to submit thoughts and proposals to the IMO. We can strengthen the hands of our individual administration to bring about necessary changes in maritime education training of seafaring officers. Think about all this. Here, a lot of expertise are here. You can think about it, saying that you can do something. There is opportunity coming up. I don't want to really hang on to this. This is the human element training and watchkeeping that subcommittee at IMO. 10th session happened in February 2024. They have already opened the door for us that you can submit. In 22 specific areas they have ticked off, saying that this can be, you can provide input. When the STCW will be reviewed, convention, so our input can be there. I will just come to that how can we do it, you will see. The 22 areas are there, from training, requirement, emerging technologies to mental health and everything. I really not going on too much on that. A two-step methodology they have devised. The first step is to look at the articles and all other, the policy thing, and the other one is the whole syllabus, etc. You have the chance to provide input and change. This is really the opportunity to change that, to do that. Establishment of an intersessional working group will be there. going towards the HTW11, which is coming next year, February. So before that, possibly there is time for us to do something. A roadmap outlining the timeline for action, including finalizing the first list of what gaps we have identified by spring 2025, HTW11, and the draft text of amendments resolution by spring 2027. So we still have a few years that we all can think about and do something. Specific areas to influence maritime administration: emerging technology on ship and ship operations, digitization, documentation, including certification, etc. Emerging, again, in education training, emerging technologies, that's what's coming. Facilitation, flexibility, remote, learning, etc. will include there. Facilitation, flexibility, quality of onboard, shore-based and workshop skill training, including use of simulators. You can see already they have identified the areas. We only have to provide input from our experience here. Flexibility and efficiency of implementation of new training requirements and reduction of administrative burdens. Requirement for C-type practical experience. List up there. I'll try to share that slide instead of, too much of time on this one. I don't think I have much time left. Psychological safety, bullying, harassment, everything is coming in there. Mental health, 21st century and interpersonal skill, flexibility, revalidation, all alternative certification to outdated training requirements. So 22 areas have been identified. People can provide input. To find solution, what can we do really? Choices: do nothing, point your fingers to another direction, possibly somebody else will do it. Maintain a status quo, we can do that. Together we must do something for smoother transition to safer and cleaner seas and better future for our planet. We can do that. We must act now. Really. Time is running. All of us can help pursue to submit a paper or two to send to the IMO Institute subcommittee with viable, feasible proposals. That's what I'm suggesting. Who to approach? Our own maritime administration, that is the signatory country representing member state. 176 member states are there in the IMO, just like the UN. So we can do that. If not, we can go to intergovernmental organization, which is there. All this Paris MOU, Tokyo MOU, all are in intergovernmental. There are 66 organizations. You can submit paper through any one of them to the IMO. So the door is really open. If not, non-governmental organizations, just like Nautical Institute, IMRS, we can approach them as well to submit papers. IAX is there, Classroom Society. So we have the opportunity. We must act now. That's what I'm saying, that we should do something. Thank you. And
thank you. Thank you, Captain Imdad, for introducing me. It's really an honor for me for present today. So I just flew from the UK. So I'm really delighted to see all my seniors here, my batchmates, and also favorite juniors after so many years. And also I'm delighted to present. I'm not going to brief anything, just going straight to the presentation here. As you could see this, my title is there, From Research to Reality, How Mars is Driving the Autonomous Revolution in Maritime Shipping. So in this case here, you can see I'm going to discuss few things what we have done in our research project. As you have seen, I'm leading one of the research center. So what we have done on the Mars and maritime related research, and also I'm going to give you some examples of autonomous shipping, what is being enforced. Our respected senior Forkanul Quader has already mentioned few of those, so that I can skip, so that will not be too long for me. So if we speak about autonomous shipping, what does it mean? It is about either it will be fully autonomous or it will be partial autonomous ships or remote control vessels. So there are the two things is about remote operation. One is there, no crew on board the ship, and another is there, also unmanned. That means seafarers actually controlling the ship from shore. So just want to give you statistics before I start. So one of the things is you can see what is the prediction we are going to face, and this is actually statistics I have taken. So you can see that global's autonomous vessel market will be there by 2030 about, and also a forecast at a rate of 19.5%. So about more than 200 billion pound investment will be there. And also you can see, you might ask, what is the present status of the autonomous shipping? So we are seeing that about more than 1,000 ships is already in autonomous. And its global market value is about 88 billion US dollars. So it is the Allied Market Research, they have given the forecast. So what is going to happen by 2030, another few years? We are expecting about 554,000 more seafarers will be enrolled. We are always in belief the autonomous shipping will be losing our job. Actually it's not. We will be working in a different language, different way. And we require more infrastructure, we require more working, more crew training, all sorts of things. So if I ask me how long it's going to take when the autonomous ships will be implemented. So what I have done, I have recently done a survey about 200 professionals. All the professionals is from IMO, the legislator, marine administrators, and also the shipping companies and seafarers what will be sailing on board the ship. So you can see that most of these people have said is not that far. Another 10 to 15 years, you'll be seeing that commercial vessels are running. So it is true, it's going to happen. But one of the things they measured about the legislation that is going to be implemented. So just to give an example, some of the things Forkanul has already mentioned, I just want to give you right-hand side about what is the IMO, International Maritime Organization, is doing about the mass implementation. So it started from 2017 and 2020. IMO has done a scoping exercise. What does it mean? Scoping exercise means that all the legislation like a MARPOL, STCW, SOLAS, COLREX, what are the changes required? So they have already carried out a scoping exercise and they have detected, okay, this is the things needs to be changed when we do the autonomous shipping implementation. Then after that, 2021, there is a trial guidelines have been given by IMO. That means when they will be doing the trials and what kind of trials is required to get the things to see autonomous shipping is running. And 2022 to 25, they have non-mandatory mass code that has been adopted, will be happening from 2025 onwards May. That is Forkanul Quader has already mentioned, 22-28 mandatory mass code development, and 1st of July 2030 adaptation of mandatory code, a new chapter of SOLAS will be added that will be giving a guideline saying that what are the things required, what are the changes required. And then it will be for 1st Jan 2030 it will be coming into enforce. That means that time we'll see that some of the traditional ships is running and also simultaneously some of the autonomous ships are running. So that will be human interaction with the machine. That will going to happen. So in case it's just to come some of the examples I have given. So Yara Backlands already mentioned that one of the Japanese ferry, Soleil, they will now fully autonomous. And that is the first autonomous ship. And all in Singapore, that also not going behind. They have got autonomous tug operation. And that is being actually accepted by APS. So that has been done 2021. One of the ship, LNG tanker, his name is Prism Courage. So they have come from Texas to South Korea, passing through the Panama Canal. That has been done about 33-day voyage along that. And also Ocean Infinity, that is based in Southampton, UK. They are actually running 23 ships remotely, 23 ships remotely from one of the center we call ROC, that has been remote operation center. So that has been all in the Amanda fleet. So now I'm going to a few things, next few slides, what we have done, some of the research project. Just want to highlight that one about the autonomous shipping. So this is one of the example we call the IGNITE project. It means Intelligent Ship Center, and our example, the future remote control operation and simulation training. So you can see that in the UK, our simulation center, what I'm actually leading at the moment. So that is the largest simulation center in the globe. And also we have got a facility about left-hand side, you can see that is about, that this is a scale model ships. So we have got a customers are coming from US, Canada, Brazil, all over the places. They come and they're getting the training for pilot training and also have officers training here. So what we have done, we have connected these two centers together, and also simulation center has been fitted with remote control operation, so that we can see that we can control that remote control ship from the simulation center. And that center is about 10 miles apart. So if you can control 10 miles, you can control about 1,000 miles. It's all are same. So this is the places you can see. This is our lake. This is the ship handling center here. So you can see that we have done experiment through the different areas. Through the island. We have done also from the shallow water. You can see buoy channels. Everything we have actually remotely control the ship from simulation center. Okay, so what we have done also, we followed STCW requirement, what you can see, and also Merchant Navy Training Board requirement. So we have done our subjective and objective assessment so that it all fulfills the criteria. So that we have done already, just to see that autonomous shipping is working. Moreover, we have also, during that, make sure this is about in the piloted water, because this is the more complicated area. So this comes from port to port, berthing, unberthing, and also the ships has been encountering about fixed targets, stop targets, and also traditional ships, so that we can be interacted accordingly. So that all has been actually carried out. So here in this IGNITE module, we have done different methods of remote controls. So you can see that we have used laptop with a visual line of sight, and then laptop beyond visual line of sight, full mission bridge with digital twins, and also full mission ship with the live camera images. And also one of the other factors we have done, that is about remote control from instructor stations in the simulation center. So that means all this method can be effective, and we just wanted to know which method is the best method to control the ship. Okay, you can see that. I'm going to give you a demonstration, especially using the laptop with front-facing ship camera, no line of sight, limited, and you can see that it has been that one of my colleagues actually remotely controlled using the laptop, but he cannot see in front of him. And here, actually full mission simulator, I'm trying to control it with the camera from the bridge. So that is there. You can see I'm now unberthing. All our camera features around that ship. So we have got basically front camera, backside camera is there, and the side cameras. You can see that also in the simulation center, another method, what we have done, we have made the digital twins. You know, our lake, we have made exactly replica of the lake in our simulation. So we have built up the twins, it's called digital twins. So this is the digital twins of our lake also. So you can see here, in the digital twins from the Tinsbury Lake and compare it to the real footage. You can see on your right hand side, we are observing from simulation center and other area scale model at the lake. So you can see that on how effective is exactly same. All these buildings and everything you can see the scene center. What actually you are doing from the scale model of the lake. So you can see that also another demonstration. So this is two navigators. One of the navigator actually controlling from the beach simulator using the digital twins, and another is in desktop as in the local in the simulation center. And also you can see the ship is being alongside at the moment and from the simulator instructor station. So you get some idea about actually what's happening. But among these two, we have found most effective one about digital twins. As if that you are on board the ship, you got over all your navigation equipment ahead of you, you have the radar, you have got your GPS, you have got your actors, everything you are running as if that you are running the ship. But one of the challenges for that one, you require your bandwidth. That means you require a good Wi-Fi connection, otherwise it's so difficult to run, but obviously it will be in the future, it will be running. So this is about, we are talking about remote control operations. So let's see now, another project we have done, we call the Maximus, that is about fully autonomous vessels. No on board, nothing is there, it runs automatically. So we have fitted the algorithm, all the colrex, collision regulation, everything. Yes, fortunately or unfortunately, we cannot change, the collision regulation. We have to follow, but it will be the equivalence approach. Just give an example of Rule 5, when we say the lookout by sight and hearing, actually that sight and hearing done now with the machine. Okay, but rules have not been changed, rules remain the same. Okay, so we have done this project with the Rolls-Royce and our lowest register, Atlas Shipping, very UK project. So this is about first in the history. This is the fully commercial vessels actually following that. So that has been tested also in English Channel. One of the Mine Hunter by Atlas Shipping, we have done that one project, implemented one of the ships. So here I'm going to show a video clip just to get an idea, actually in the simulation center, and how I have done about the Maxima project. So it is about a minute video clip here. And Rolls-Royce was a leading partner for us. This is our Warsaw's old campus, where we have a building, we have got all these simulators are there. One of the simulations has been converted full autonomous, so that is man versus autonomous. That also we have done with the project. So you can see this is about simulation, but if you can try out in simulation, it is exactly the same with the simulation giving you real data, real information. You can see this is the fully autonomous vessels that is moving with it about all this. So we have got different types of ships around, and this is from the remote control. Sorry, this is the ship instructor station. So how it has been working, so how this architecture is there. You can see that we have got first stage, there is a 3 stage there, we call ODA, observation, detection, and action. First stage, in the observation stage, like sensor and data, because all our GPS, gyro, and also all this AIS, it gathers all the information around that ship. And all this data has been collected, and then it became a data fusion. With that data fusion, with the help of our electronic charts, it gives about operational pictures around me, okay? And then it's coming to the autonomy, executive collision awareness mission plan. That means it follows the passage plan from A to B, and while it's following that one, it's go to A to B, but at the simultaneously, it also see around us any of the targets are there, any of the other ships are there. It acquire all the targets and give the algorithm all the full following that 101 requirement using the same call recs. The call recs is not different, it's the same thing. And then it tells you about navigation demands. It tells you about your steering and also tells you your telegraph, okay, so about how much speed is required and what. So that this will command. And that is about decision making stage. And after that, navigation demands go to the control interface, and goes over, we go to starboard, slow down, give a maximum speed, that kind of give a navigation demand. So all these things have been actually tested in the simulator and also real ships. As you can see that this is the Mindhunter ships, what we have done here. So this is the one about, we have got more than 100 ships been involved. And there about 6 bridges have been involved. One of the ship on the left-hand side, you can see that has been about remote control ship, and all others are actually manned vessels. So we had a manned vessels and autonomous vessels. So one of the beauty was there, as a training provider, what we have done, we have not told the student this is the autonomous vessels. So we are telling them, okay, there's the normal ships around him. But that ship, we have found autonomous ships is always follow the rules of the law. But the human is different. Human want to take the risk. They always say, so the next slide you can see that. One of the things we have done, tested, you can see here we have got different ships. You can see this ship is coming, autonomous ship. And there is a few ships that they are warships. But autonomous ship has a large alteration of course and go behind that. Okay, but whereas the human vessels, some of them has gone forward of them, some of them got back of them. But human wants to take a risk and they don't have to have that. But autonomous vessel was much more safer, and they have taken the right decision. What we have observed. But one of the other challenges there about like a good seamanship practice. Because good seamanship practice, autonomous ships cannot take, because that you need to feed in. So what we have done in that case, we have asked 10 mariners, 10 experts, what do you think that in this situation, what's going to happen? So we have a collective approach, and then we feed an algorithm for that ship. Okay, so these are two things we have just finished, this project. So recently, my team and myself had awarded one of the big projects, Horizon Europe projects there. So that will be a little bit different. It's not a shipping, it's about keeping the security in the Europe. So you can see in this security what we have done. We have used UAV, that means unmanned aerial vehicles from the drone ship. They'll be observing any of the ships is coming. Then we have got USV, under surface vessels, and also UUV, underwater surface vessels, and submarine cables and everything. So main idea for this project, just to see about any illegal activities is going on around the coast. So that is the maritime boundary surveillance. So this is the project we're starting. So this is the 1st of October, started recently. So I'll be going to next week to have a meeting with them. So that is actually we have recently got, and this is the AI, what has been Forkanul was saying. So that will be detecting all these targets, any illegal activities or environmental pollution, all these things have been working here in this project. Okay, last slide. So this is one of the things there. What we have done recently, we have made one of the ship. That ship has been made in your simulator, and this is the rotor ship. You can see there's 2 rotors are there, and that actually is spinning, and that's thinking about wind propulsion, wind assisted propulsion. We take the advantage of that. We have found we can save our energy about 20 to 30% about using this sort of ship. So that is it's not autonomous, but we are trying to do that like using the bar facility, so that we can remotely control the ship from the shore, so that we can actually also get into advantage. We want to go back. You know that IMO is looking for a decarbonization by 2050. So to achieve that, one of the strategies they are using the wind propulsion system, and that could be beneficial, and that is a huge impact. We are going to start our first course will be 28th of October. That is about, you can see UML, that is Union Maritime, that limited. They have got a few hundred officers will be coming for the training, for wind propulsion training. So that is one of the things we are just trying to highlight here, because that will be also can be converted to the autonomous shape. So that's all from my side. Any question, anything? I'll be very delighted to do that. No problem. We can work together.
Thank you very much, Zakir sir. There is a good news, or I don't know whether it's a bad news. There will be no Q&A sessions. The reason is we are running out of time. But anyway, all the speakers are around. We'll have a 3 days session. So if you have anything to ask, to check with the speakers, please feel free to contact. And I think with permission of especially Mike Watt, we can share the slides to others. Yeah. So those who wish to have these slides, presentations, we can share, and you can have all these informations and contact details. So I think that solves the problems. Okay. Our last speaker is, anyway, I don't need an introduction to Dr. Khorshed Alam sir, okay, who will be sharing with the challenging part, I think, the focusing on shipping net zero 50 strategy. We don't know what to do actually, or whether it will happen. With a wealth of experience in maritime field, Dr. Khorshed has contributed immensely to maritime industry. Dr. Khorshed Alam is the Senior Vice President, Maritec Group, and prior to this, he was the Managing Director of the BMCS Group. Dr. Khorshed served as the Vice President and Regional Manager of Maritime Advisory of DNV-GL and as the Managing Director of Future Ship Singapore between 2012 to 2018. He served as the Director of Engineering, Energy Management, Environment and Research Development in APL, which was Neptune Group, from 2006 to 2012. Dr. Khorshed is a chartered engineer and a fellow of Institute of Marine Engineers, Science and Technology and RINA. He acquired his Bachelor of Science in Marine Engineering from Australia. Subsequently, he received his MSc and PhD in Marine Technology from University of Newcastle upon Tyne, UK. He also received his second PhD in Environmental Science and Engineering from the National University in Singapore. So please welcome double doctorate Dr. Khorshed.
Hi, it's a later part of the evening. I'm standing in between your dinner, and I was told to make it as brief as possible. Can you hear me? Yeah, okay. I'll try to do that, but the good thing about being the last speaker is that I can wrap it up more or less what we have learned from the previous speaker, not what I prepared beforehand and a product off the shelf to produce. So before I go to that, and before that I must give compliments to BMCS President and all the executive members and all our seniors here today, including from first batch, my teacher in academy those days, and many others have flown from different parts of the world. I really would like to appreciate their taking trouble to join this event. So before I jump onto this, the title says Shipping Net Zero 50 Strategy. And one thing I have learned is that when you talk about strategy, you are talking about long-term thing, not the next year or the year after. Those are sort of action plan or sort of annual plan. So strategy is something like 5 years or beyond, right? That is one thing. But one thing people normally don't do is that they form a strategy, but straight away from strategy they jump onto action plan, what I'm going to do next year or the year after, in line with the strategy. What is missing in between is a scenario planning, is a scenario plan. And that's why we often are caught up. In a sense, I used to remember during my time in DNV, we had been brainstorming from our strategy planning that what should the action plan. So I thought of the idea that all the strategy had been made based on the fuel price will keep on going up. I said, what happens if the fuel price goes down? All started laughing, it never happens. But then over time, after 2-3 years, the fuel price really went down. But then all the strategy we had, that goes down to the basket. So here we are talking about all those you heard today with the due regards and compliments to all the speakers. Let's think of this strategy for the future, be it human, be it machinery, be it technology. Let me touch on a few of them. One is, once, long time back, I gave a talk, not say where I do teaching in NTU and NUS here, but it's another university here, it's called University of Social Science. And among the very young students, and they are very bold nowadays, these Gen Z sort of students, he stood up and asked me, sir, is shipping going to die one day? What a question. Is shipping going to die? I took a pause. I was shocked to receive such a question. But when I gave the answer, it's a possibility. It's a possibility. So now try to gel this on the scenario planning I'm talking about. Let's talk about the shipping. As you have seen, Mike has shown he's working on some ship moving at 80 knots. Is it 80? 18. 80. Okay. Okay. And in Singapore, by the way, if you are not aware, there's a police board. Again, it goes well with Zakir's autonomous. This is also autonomous, and many Navy ships also autonomous, moves at a speed of 60 knots in Singapore. So what I'm saying, that 60 knots or 80 knots is not going to roam around the world in the ocean. So shipping, we know, technology-wise, it has hydrodynamic limitation. It moves at best, in today's model, around 30 knots. And then think of what is happening around the world. Other sort of mode of transport we have is the aviation. Aviation moves at the speed of around very close to 900 to 1,000 miles per hour. And then in between we have locomotive, the train. It moves at the speed of, now not the local train I'm talking about, those maglev train, what you see in China. And these are in China's One Belt One Road, there's Silk Road Initiative. They are actually banking on those kind of transport. Maglev train, magnetically alleviated. They don't touch the rail, they simply float up and move. Reduces the coefficient of friction. Moves at the speed, half the speed of the plane, around 450 to 500 miles an hour. And then, if this is the case, if that's the way it is connected from Asia to Europe and all over the world with this kind of maglev train, and it can carry a similar kind of amount of cargo what the ship is carrying, then ship becomes sort of redundant. In addition to that, even some ambitious guy, those kind of disruptive guys like Elon Musk, he came up with the idea of Hyperloop. So he joined that magnetically alleviated that train concept, plus add some kind of vacuum technology and make it a Hyperloop, make a tunnel, and then magnetically alleviated train kind of thing, and at the same time you suck it. So what happens now, the speed is tremendous. So now 450 becomes like 700 miles an hour. From east coast of America to west coast of America, my APL days, a truck, a lorry would take around 4 to 5 days to bring one container. And it will be done with the Hyperloop within a matter of few seconds. So this is only one example. Then when you talk about, and then what will happen is that when we were kids, we have read those kind of children's story, Peter Pan's, the ships can fly, right? And here we're talking about ships won't fly, but ships competition will fly, one level. And you learn about I'm also going to talk about that alternative technology. It's not really fully overlap, but strategy must include that alternative technology, right? In that regard, before I jump onto that in my slide itself, I would like to float an idea, is that all this organic kind of alternative technology we see, most likely, that's my belief, that will not be there. When you talk about 2050, you want to have net zero, you need some kind of disruptive technology. And the height of it, actually, it is a nuclear. Make it very straight, nuclear. And I'll show you what is the sentiment of the people about the nuclear. But before that nuclear technology, people often think, no, not nuclear. But nuclear, just for your information, nuclear, after America has bombed Japan with the atom bomb, right, in 1946, then came a news in, I think, Washington News or somewhere. I had the copy of the front page. I was not born then. But that says atom for peace. That means they have built a nuclear ship in 1949, if I'm not mistaken, for merchant ships. The ship's name is Savannah. You can Google it and can find Savannah, a nuclear reactor propulsion ship, followed by Japan, Germany, and Russia. All three of them built one each nuclear-powered merchant ships. So nuclear is not it's not that it was not really done or it's not viable, it is there. Till today, I think 11 to 12 Siberian tugboats are actually nuclear powered, ice-breaking tugboats, right? Nuclear powered. And talk about the Navy, of course, nuclear submarines all along is there, quite some time. But the nuclear in future, we are not going to use the same nuclear of this technology, fission. Fission means splitting the atom. That creates radioactive and all those things. We are talking about the fusion technology. That is the atoms to be fused together. The same nuclear fusion, actually, what we see is being actually is being formed on the sun itself. That fusion. That fusion technology actually is advancing tremendously. And Zaki said something about when it's coming, he's autonomous, 10 years, 15 years. Nuclear fusion also, the timeline is that within 15 years, most likely we'll have nuclear fusion. Now they tried, they can't control it well. For a few seconds, it's very successful. Next 15 years, most likely nuclear fusion will come. If it comes, then think of the consequences. And all these things that you talk about, and Captain Forkanul talk about, that artificial intelligence, whether it take away people's job or not. But the point is that this is a good thing to look at, because even our caretaker government back in our home, he gave a very nice speech in the United Nations, and he was also advising the whole world to be cautious about going in the direction of AI, so that it doesn't have any social impact, people don't become unemployed and all. We really have to take this into account. So coming back to this nuclear, so if nuclear fusion is successful, and then think of it, if it is successful, and they say even the footprint of that nuclear fusion is very small, the reactor. You can put at the back of a lorry even, and it's a nuclear reactor. If this is going to happen, then you can have nuclear, every part of the world. Be it Ghana, be it Timbuktu, somewhere, everywhere you can have nuclear power. And you saw Mike's note, we talk about the hydrogen, e-hydrogen. From there you can make e-methanol, e-ammonia, whatever you want. So main thing is the hydrogen. Where the hydrogen come from? Because we need electricity for that. It's the electrolysis process or water reformation process, whatever it is. We need electricity for that. Where the electricity comes from, as Mike mentioned, some coming from the coal power plant, so it becomes blue, it's not really green. But what I'm saying, that electricity, if it comes from that nuclear source, it is green, and it is from any part of the world, and then what is the implication? Implication is that, think of it, the consequence. Just like I said, that student asked whether a ship will fly or shipping will die. Similarly here, one business will be totally out. What business is that? Tanker business. We don't have to carry any more energy in the tank. In the tanks, one country to another. Every country is self-sufficient with that electricity. They can produce their own hydrogen, they can produce their own energy. Right? So I mean, it goes on and on. The third one, before I jump onto my topics, I'll go very fast on that. But third one is that, let's not forget, we are talking about this organic, everything organic. In our mind, we are brainwashed about organic kind of development. Who will really move it? If we think that classification society, if we think of Epibola or companies like that, it may not be necessary. We should be very careful. There are some non-maritime enterprise or institute. Good example, Google. What Google has to do with the autonomous car. So they are the one. If they come, Google comes, Amazon comes, and they take the lead, and then it's up to them how they do it. And they are the mover. So come back to my original point I brought up is that all this strategy, you should put the scenario planning after strategy planning. If nuclear comes, what happens? If autonomous vessel comes, what happens, right? We contradict ourselves. Though I'll be in a bit of contradiction with what Zaki mentioned. Autonomous vessel comes, the crews will still be there. I have my doubt, but that crews only called crews. Yes, the job will be there maybe. Maybe the answer will be job will be there. But not the crews we train today. This kind of crews will be redundant. We have to accept it, right? So if autonomous vessel comes, what STCW got to do with it? You have to write different set of rules, all control from shore, how to do it, right? So all these things we have to take into account. So strategic planning, after that it should be that scenario plan, right? So based on my presentation today, it is based on the boundary condition is the organic one. I did not inject any disruptive technology or disruptive idea, right? So based on that, let's move on. So right now, most of the shipping company in a transition, see, I was shown a card, 10 minutes left. I'll finish it. Transition dilemma. It's not really fair because I shouldn't be penalized for the other speakers. Transition dilemma. They're suffering from a transition dilemma. Which fuel should I use? Some of them covered by Mike, so I'm not going to cover that. The regulatory and technology pathway is not clear. So they are waiting for that. Regulation, as you heard, they're waiting for regulation, waiting for that what kind of technology comes in, they're waiting for that. But companies will gain advantage. They don't realize they will gain advantage if they really commit to net zero. And you heard of net zero. There's a lot of confusion, net zero, net CO2 and all these things. Let's talk about the terminology got to be right. It has to be net zero emissions. And it has to be the climate neutral. Because we're not talking simply of CO2, many other greenhouse gases are there, right? Then players can benefit from improved brand perception, better customer attraction and retention, and greater financing opportunities. Some of them tangible, some of them intangible. Brand and all these things. Other one, we talk about financing opportunity. That means can I get a bank loan, right? So this mix of this. By taking action now, they can create effective solution and influence the legislation. That means to say, if we embark now and we on this kind of journey, then you discover the alternative fuel suppliers or classification and all these things, and you can influence that we have this problem here, we have some shortcoming here. You can't bring in the rules, you can't bring the cart before the horse, right? So to start decarbonization, shipping must make tough decisions. Investment got to be there, technology and collaborative partnership, collaboration. And as you heard from even Zakir, a lot of collaboration going on, be it Wärtsilä, Rolls-Royce, my DNV channel, so we work with the Rolls-Royce, we work with the ERA, the one it was shown before, right? So other thing is that in an uncertain environment, company's strategy, that will strengthen your business today, but in position for the future. You can't sacrifice everything of today, say today I make loss, but I'm prepared for the future, right? You have to take into account. So what could be a strategy? I have borrowed some, it's a combination of some findings from the world-renowned consultants. It's not my own slide. So best way maybe is I believe is from BCG, the company transition strategy, how you go about it. Develop a low carbon business strategy, climate proof operation, as I mentioned just now, and engage transparently with the stakeholders. At the end, you'll be part of the ecosystem, the collaboration. On the left-hand side, you see there, that is actually, that with decarbonization drivers. Who are driving it? Have we realized that we talk about all those things, alternative fuel and all, and where it comes from? The people cry for it. They say environment is getting warmer, right? Fine. They elect their sort of member of parliament, whatever it is, to go to the parliament and make sure the climate, they do something with the climate. They do something, bring rules, and then alternative fuel has to be used, though it is expensive. And the goods are transported with the, this kind of expenses. At the end, those who cry, they pay for that, right? But nevertheless, it comes from customer demand, right? Customer demand it, that's why you do it. So the driver is there. Regulation will drive it, right? And financing. And this is one thing what we see for a long, long time. Coal power plant, COP25, COP26, COP27, COP28, who's got COP and COP and COP. But people don't stop producing this coal power plant. On the paper they agree, but go back, every few weeks, one new coal power plant coming up. Best way to suffocate that is by don't finance them. And that is why today we have the Poseidon principle, that the 37 signatories are there, the bank signatories are there. They are not going to finance you unless you have a good sort of ESG, environmental, social governance kind of thing, sustainability report, right? What you're doing for the environment. Before they look at the ROI, return of investment, they ask you what sort of ESG you have. The transition lever, that is on our side. So that is on that is the driver who's driving it. On the right side, you have this operational efficiency, technological efficiency. That's the one operator will be doing. And the future fuels, right? So that's where the dilemma they have. This one going to show, this one all of us know, 2050 target. So here if you see, at the end I said, who pays for it? Customer pays for it. If customer pays for it, then I'll provide, right? So look at that. On the left-hand side, you can say, will they pay the premium? That all the statistics taken today, 71% willing to pay a premium. But how much? Only 2% premium they will pay. They are ready to pay. 2%. Going forward in 2050, right? Premium in the future. 63% willing to pay. Here 71% willing to pay. But here 63% willing to pay, but they'll pay a bit higher, but they don't know how much. I didn't put the figure there, how many percent they will pay, right? So now what is needed for decarbonization? Around $2.4 trillion is needed for decarbonization. So we are talking about a big amount. Out of this 2.4 trillion, 1.7 will come from alternative or the future fuels for decarbonizing. 1.7 trillion. 1.5 trillion, those energy providers, like big oil majors and all, they will be needing that money. 1.5 trillion. Operators will be spending around 0.2 million. So together is 1.7 trillion, right? And on top of that, alternative fuel cost, of course the operator will have to again 0.7 trillion in operational and technological efficiency. So they are not looking at just for the fuel, they pay 0.2, but in addition to that, this is very important, the last one. They will be spending 0.7 trillion for operational and technological efficiency. And what it means, I'll show you. And this is the graphical representation of that. 2.4 trillion, I say, and you can see here, 0.1 trillion for digital solution, 0.6 for the technology, and again on the right-hand side, that 1.7 trillion just now is the operator will be using for the future fuel, and then onboard storage, hydrogen production, fuel synthesis, all these things. So this is basically the breakdown of that 2.4 and 1.7 trillion. And just now we talked about operational and technical efficiency, right? Technological or technical efficiency, right? So far, as per IMO, 20 to 30% technical efficiency have been achieved from 2008. From 2008, we have achieved already 20 to 30% operational and technical efficiency. But there is room for improvement, and we can improve by another 20 to 25%. That is altogether more or less 50% of that come from the operational efficiency, right? And the rest will be taken care of the future fuels. So what are the operational efficiency? We know very well. I don't have to elaborate on that. Operational efficiency, you saw that SEMP, Ship Energy Efficiency Management Plan, it should have all those things, vessel routing optimization, and the container optimization, reduce ballast, and all those things, blah, blah, right? And then don't, again, ignore the asset optimization, right? Analyzing the data from the ship-based sensor, then you should have enabled faster and better decision by replicating the equipment of the virtual environment. Last one is build or buy digital capabilities. And that's why you can see that large companies, most likely, they will be using in-house capability, and smaller companies, they will take the help from the third party. That is about, and the transition of operational efficiency. Okay, we have to move. Okay, I'm here. 5 minutes, but you don't stop it then. Someone move it? He said trying. No short of trying. Okay. Okay, so operational efficiency I've seen. Technological efficiency, again, we know that a lot of things can be done with regard to like drag reduction measure, and yeah, you saw SAID and all those things, right? Those kind of technologies coming back. And hull coating, variable frequency drive, improved propulsion system, many of those, right? And then you can align new building programming with emerging technologies and participate with the shipyard. That's where the collaboration comes in, right? How do you cooperate with regard to even technological efficiency? Move to the next, please. So then two things we have seen, operational, technological. Last one is the fuel, right? So the fuel actually, alternative fuels are essential for the industry. Yes, we understand that, but we have to have a lot of structural change. One thing we haven't touched on, we touched on the engine and all this thing is fit for that, but the storage, Mike has shown something, whether you have seen or you have noticed or not, those kind of, what I call L-shaped thing, the storage. And he's talking about the volume, energy intensity, how much space it takes. So that's why the big structural change is needed for that. Storage is a big problem. New vessels capable of running zero emission fuel will have to be designed and built. And then commercially viable zero emission vessel must start entering global fleet by 2030. You don't start now. And that's why most of the people are waiting. Because the ship life is only 25 years. If I build something very advanced one, it's not going to last up to 2050. What do I spend so much money? So you start looking at 2030, right? Okay, next. So a convergence is happening. And at the end, I simply say that in between, I think Mike also touched on that, biofuel is available today. And he also touched on that. Biofuel is one way, it's written here only for the short kind of transition period. But I would think that biofuel will be there in future in a hybrid form. Bioammonia, biomethanol, and all these things. So bio will be there one form or other. Oh, don't. I know you're rushing, but please. For short-haul vessels, electricity will be emerging as again alternative. And as you know that in Singapore, the first electric vessel already started with the Island, right? So it's going to happen. Long-haul vessel, I think ammonia, though is again in contrast with what Mike has shown, ammonia, right? Ammonia may not be the one, but I think ammonia is the one because my one is backed by some other, again, Clarkson or someone had done this stuff. This is the thing, the debate going on, some say this, some say that. But let's take one part. Here I'm saying ammonia most likely will win. Next. So here you see alternative fuel decision based on the use cases. You see ship by ship, bulk carrier, liquid container vessels and tankers and all, right? And battery operated, the electric vehicle. Then you can see which vessel will be suitable for what. Last one you see ammonia, it will be suitable for ro-ro, bulk carrier, liquid gas carrier, container vessels, and all kind of vessels. But for some, like battery electric vehicle or ro-ro vessel will be more useful, and it will be based on the use cases. Next, please. Next. So some companies are positioning themselves for the zero emission engine technology, but engine makers working on it. Is one thing what they are doing actually, in case some, as I said, people are suffering from transition dilemma, which fuel should I go for? Good news is that engine maker, they have published many news on that. That means they will supply you some kind of conversion kit. So you just you can order even a conventional engine. Tomorrow you want to burn ammonia, just change the kit, you can burn ammonia. You can change the kit, you can burn LNG. You can change the kit, you can burn methanol. So they're coming up with this. So this is the good news. That simply means all the 90,000 ships or 60,000 ships right now we have, they have a potential for retrofitting. That is the thing. But if you depend on the new built ships burning them, especially for that kind of fuel, then it will take long time to do that, right? Okay, so here we are saying, okay, hold on there. So retrofitting, we have to look into retrofitting because if you don't depend on simply the new ship, that was the shortfall of the EEDI thing. It was applied only for the new ship. That's why the gain wasn't much. That is why 2023, they applied the same one for EEXI, existing ships. That's where the big volume comes in. So for retrofitting, all this retrofitting is good thing is that retrofitting is going to cost you less, provided you build ship for the dual fuel engine. That means the dual fuel from the very beginning, make it dual fuel, and tomorrow you want to retrofit, it's very easy to do that. And usually the company is 10:1. $10 million compared to $1.1 or $2 million for dual fuel alternatives. From the traditional one, if you want to do through the traditional path, that means to say only one fuel, 10 million compared to retrofit 1 to 2 million. Okay, I think we can skip that. So at the end, what we are looking at, retrofit and new gear, all the projections show that eventually it will be 50-50. That means 50% will come from the new build and 50% of the alternative fuel will come from the retrofit. And that's a good thing, and that possibly is our aspiration, right? Okay, next. And the transition strategy. We're coming almost to the end. So what we have is fossil fuel, as I said, the blending. This is the easy option we call drop-in fuel. Biofuel, you don't have to modify anything at all. You just drop in fuel, and you can gain and gain. Of course, biofuel price is a bit higher. Cost delta is, Mike was showing 240, but latest I saw, actually it's plummeted. Now it's $140 today, you know. So B24, right? $140. So what's your gain? Because you have short of energy. Biofuel has 10% more oxygen. It displaces the carbon and hydrogen, so you don't have much energy. Around 10% less energy. That means you have to buy more biofuel for the same energy content. But then again, EU ETS and fuel EU maritime, if your ship is going there, if you minus it, you see that the gain is still there. Right? And the last one is that, again, in the development of the fuel, the collaboration is very much needed for that. Okay, next. So these are the one. Again, you see that from the efficiency lever and the new fuel and the power, right? So you can see the efficiency lever just now is operational and technical efficiency. That from wash planning, how many percent coming, and all those things, right? And the green color means deployed at a scale, and the black one means no adoption as yet, right? And then you can see that on the right-hand side from new fuels, and this is coming from the shipping company's report, widespread from all over the world. Next. 2030, 2050. So again, which fuel will come in, and what percentage and all these things, 2030 and 2050. Again, it's coming from some kind of survey form. Next. And here is a similar thing. It's saying that at the end, what is interesting is that even 2050, there will be some. There are many studies done even from Singapore, GCMD, Global Center for Maritime Decarbonization. They think even in 2050, the fossil fuel today, not only fossil fuel, VLSFO today, what we use, it will be around 35%, still will be there in 2050. But, there's a but. Even though you use VLSFO, most likely there will be abatement technology, that means you capture the carbon. So you're not going to emit the CO2 to the atmosphere, right? And here it shows that the adoption, right? That is to say, if you see the first one, the industry standard. Black one is 2030, and green one is 2050, right? So if you see that some of the biodiesel, that 2030 actually is already there. You can see the viable option adopted biofuel, biodiesel already there, right? And if you look at the ammonia, just now I said, the ammonia, you can see blue ammonia, right? Blue ammonia actually is like viable option, like in the green one, you can say 2050. So it is happening. Last on the nuclear, you can see that again, 2050 most likely will be nuclear. In a scale where only some niche segment, not widespread. So that is the survey result. Next. With regard to engine, similar kind of picture. Okay, next. Availability and the cost of the fuel, right? Mike has covered some of that cost and all these things, so I'm not going to touch on that. Next. This is the last slide. So here you can see decarbonization targets set by most publicly listed companies, and here you have two. One is the decarbonization targets, other one is the net zero target. Interesting thing to note is that 2019 to 2020, there is a jump of two times, 8% to 15%, and even for decarbonization target 589 to 939, almost double. So that means people really, thinking wise also, it's becoming sort of exponential. I think that's all, isn't it? Yeah. Thank you. I have to
Okay. So, I think we have done all the speakers. Thank you very much. And Bangladeshi Marine Community Singapore, I rather should say Bangladeshi Marine Community is very thankful, very delighted to have all the distinguished speakers here. So we have token of appreciations for all the speakers. May I request BMCS President Dito sir, along with Captain Jakaria sir, General Secretary Shakat Hussain sir, and Abu Hassan Roni. A special invitation for him because Abu Hassan Roni is basically working for the energy. He is doing, he's basically emission manager at MISC, and he had a MSc degree from Maritime Energy Management from World Maritime University, Sweden, and he's doing PhD for zero emission vessels under University Malay Technology, Malaysia, so to assist me. So I would like to invite all our distinguished speakers, okay, to come on the stage one by one and receive the crest, please. Mr. Mike Watt,